Okay, so my name is Kevin Lister, and I'm affiliated with the Climate Institute in Washington. And the Climate Institute is an NGO. It's been involved in climate change for 30 years. It was the first NGO dedicated towards climate change. And the focus is on climate education and climate policy. So to that effect, we've just recently completed a major submission to the UN Tanaloa Dialogue, where we've called for the maximum temperature above 1880 to 1910 baseline to be 0.5 degrees Celsius rather than the 1.5 that's currently being used as a target in the current COP agreements.
You know, we're actually, and a lot of people talk about the 2 degree, and business as usual will lead to 3 or 4 degrees.
Correct, so yeah, but business as usual will take us well over 3, 4, 5. It'll take us into completely unknown territory. To get 2 degrees is impossible. The INDCs that have been agreed in COP will put us nowhere near 2 degrees. They'll put us even further away from 1.5. And that gap between requirements and intent is growing all the time. With the legacy CO2 that we've got in the atmosphere, getting to 2 degrees is virtually impossible. Even if we went to a zero carbon economy tomorrow, we still can't get to 2 degrees.
So why is it so important to go to 0.5 only, to actually decrease by 0.5 degrees from where we are now?
Yeah, so it's the reason why it's so important is at 0.5 degrees above baseline, we started to see fundamental changes to the ecosystem. So at 0.5 above baseline, we started to see the coral reefs bleaching globally in 1980 when the temperature was 0.5. Between 1978 and 1986, again, around about 0.5 above baseline, Peter Wadhams was measuring changes and loss of sea ice volume. Round about the same time, with a temperature rise of 0.2 on the seabed, then Jim Kennett was observing methane releases coming off the Washington coast of the US. So even at 0.5, we've got ample evidence that serious and dangerous changes were happening to the ecosystem. The changes that we're seeing now at 1.16 above baseline are really starting to emerge to be catastrophic and also to be amplifying as well. So really we need to think about taking temperature back towards 0.5.
And that implies geoengineering, and that is?
That implies solar radiation management. We need to be really careful about the terminology. Geoengineering gets branded around as some kind of horrible solution. We don't want to do geoengineering, but we see no solution for it. The specific type of geoengineering that we need to focus on is solar radiation management, and that's looking at ways of increasing the albedo of the planet to start reflecting the heat away and to restore the radiative balance. We believe that it would be impossible to take CO2 out the atmosphere quick enough to stabilize the climate system.
And this has some benefits, of course, but some risks as well. Can you compare the risks of doing the solar radiation management? Sure. with not doing them?
Sure. Yeah, that's a really good question, actually. A lot of people say we shouldn't do solar radiation management because the risks are too great. Well, where we are today is at 1.16. We have extremely good climate change models that tell us really, what our climate response will be if we cool the planet from the 1.16 back towards the baseline. That keeps us in known territory. And we're not denying that there might be risks. There probably will be, but those risks are known and quantifiable. However, if we go the other way, if we go to 2, 3, 4, 5, 6 degrees, we are in completely unknown territory. We have no way of knowing if the climate change models will be valid, and we have no way of knowing if our political systems will survive. And really the general conclusion is probably our climate change models won't be valid, and certainly the political systems that we see at the moment won't survive that kind of temperature rise. One really important point in this as well is in February 2018, we had a catastrophic melt of the Arctic ice cap, a completely unprecedented event. So the ice cap was melting in February. And in that week, Russia, China and America all announced upgrades to the nuclear weapons systems. So basically the global response to those kind of melts of the Arctic and those clear climate change warnings is to upgrade our nuclear weapons systems. That really does not give us any great deal of confidence that our political systems are going to survive at 2, 3, 4, 5, 6 degrees temperature increases that we're heading towards at the moment. So yes, there's risks if we do geoengineering, but the important thing for us to start doing is looking at the comparative risk between not doing it and going into complete unknown territory to doing it and being in risks which we can pretty well predict and manage and most likely control.
Right. Where do we find more information about this?
Well, we've made the submission to the UN Tanaloa dialogue, so you can Google the submissions to the UN Tanaloa. We'll put some material up on the Climate Institution website as well.
Thank you very much.
My pleasure.